Alright, so in this video we're going to pick up where we left off on the review guide and talk about question 42. Right now we're talking about conic sections, which is relatively recent, so hopefully you have some familiarity with it. And in this question we're basically asked to identify the graph of the given equation right here. Now you can see from the choices that this is either an ellipse or a hyperbola, and the way we know it's an ellipse is this plus sign. Okay, if it was a hyperbola, we'd have a minus sign there. So I can pretty much right away narrow this down to choice A and choice B. Looks like the A is missing, so I'll add it in. Now, it's hard to tell which one it is right now because the ellipse is not in standard form, and standard form of ellipse should be set equal to 1. So what I'm going to do is divide through by 72. Here, here, and here. Because 72 over 72 is 1, and I will over here get y squared over 36 if I simplify that fraction, and here I will get x squared over 9. So what we can deduce from this then is that with the x-axis I'm associating a 9. Now remember, I need to take the square root of that, and so on the x-axis I should go out by 3. So it looks like B is going to be the winner, but just to be sure, on the y-axis, see with y we've got a 36, and I'm going to take the square root of that, so I want to be at 6 on the y-axis. And so B is going to be the winner. A is very close, but they flip-flopped it, and they've got 6 on the x and 3 on the y. Okay, so going on from here, basically the same question, but this one is already in standard form. Notice that it's already set equal to 1. So again, if I look at the x-axis, this should be going out 6. And keep in mind that because of the plus sign, this 2 is an ellipse. So if I go out 6, this one's kind of hard to look at. Let's see, 1, 2, 3, 4, 5, 6. I think actually both of these go out 6, so can't quite narrow it down yet. On the y-axis, we should go out by 8, right? Because the square root of 64 is 8. So I think I'm pretty convinced B is not the right answer. I don't think it goes all the way out to 8, but it sure looks like C does. So C is going to be our winner. Alright, let's finish up our discussion of conic sections here on the next page with one last question. And this one actually finally gets into a hyperbola. I know it's a hyperbola because of that minus sign. Ellipses and hyperbolas are very similar, but the key difference is the sign. And because it's a hyperbola, I can knock off A and B directly. Now, the interesting thing about C and D is that one of these is horizontal and one of them is vertical. So without making any effort into this, I really just need to look at my equation and see which one of these I have. And it's all about the positive term. If x squared is the positive term, it's horizontal. If y squared is the positive term, it's vertical. And the way I remember that is x means x-axis, and that's horizontal, and y means y-axis, and that's vertical. And since we can clearly see that the y is the negative, the x is the positive, this has to be C. You can also put this in on your graphing calculator, but this one's pretty tough because you have to get it all solved for y. Alright, now we're going to move on into our combinatorics and probability stuff. So this has been a couple months since we've done this, but this problem 45 is a counting principle problem, and we did quite a few like this, but basically this is like the Applebee's Choose 3 problem we talked about. We've got 3 kinds of salads, 2 kinds of soup, and 3 different drinks, and I'm going to select one to make a meal. I've got 3 choices of salad, 2 choices for soup, and 3 types of drinks, and if I use the counting principle and multiply those together, I will end up with, let's see, 9 times 2 is 18. So the answer should be letter B. 46 and 47 get into talking about some factorials, and remember that a factorial means the number multiplied all out. So for example, 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And of course you can do these all by hand, you know, divided by 5 factorial, 5 times 4 times 3 times 2 times 1, and then the 5s cancel, and the 4s cancel, and the 3s, and the 2s, and the 1s, and really it's just 7, whoops, the 6 is in there too. 10 times 9 times 8 times 7 times 6. Remember, though, that you do have a factorial key on your calculator that can save you some effort. And it's under the math menu, and then probability. And if we do 10 factorial divided by 5 factorial, I'm doing it on my calculator right now, I can very easily decide that the answer is 30,240. So again, this question's really just getting at, do you A, know what a factorial is, and B, can you use your calculator to evaluate one? Same deal for this guy, though I would recommend, since there's a couple of things in the denominator that are both divided, I would use parentheses. So 10 factorial divided by parentheses, 6 factorial times 4 factorial. And you could always do the 6 factorial, 4 factorial first if you're uncomfortable with the parentheses, but you should end up with 210. Doesn't really matter what the number is, really just going for, you know, do you know how to enter it into your calculator. Right, continuing the idea with counting a number 48 here, 13 people entered a race, and if there's no ties, how many ways can the first 3 places come out? A couple of ways you could do this problem. You could do it just straight with the counting principle. You know, here's first place, second place, and third place. And since there are 13 people, there are 13 ways first place could come out. And then once the first person has crossed the finish line, there are 12 possibilities left for second, and finally 11 possibilities for third. The other way you could do that is you could say 13P for permutation, 3. And remember, permutations count the number of arrangements, and that's exactly what I'm asking here. I've got 13 people, and I'm going to arrange them, arrange 3 of them. And keep in mind, order matters with permutations. First place and second place are meaningfully different. Gold medal versus bronze medal, it matters. So that's why I'm choosing a permutation. If I didn't care about order, then I would go for a combination where I'm just looking for groups of 3 where there is no distinguishable difference between first, second, and third. No matter how you do it, though, you'll get 716, whether you use counting principle or a permutation. Okay, 49 says, find the number of distinguishable permutations of the word crayon. Now, if we look at crayon, all the letters are different, right? All the letters are different in crayon. So it's simply going to be, there's 1, 2, 3, 4, 5, 6 letters. It is simply going to be 6 factorial, which is 720. Now, if this was a little different problem, let's say tree, in this case, I can't just say that there are 4 factorial permutations because every time I swap the 2 E's, I get an indistinguishable word. In other words, tree E is not different from tree E. It doesn't matter if I switch those two. So in this case, I have one extra step, and that is a divide by 2 factorial for the 2 letter E's. If there were 3 E's, I would divide by 3 factorial. If there were 10 E's, I would divide by 10 factorial. But in 49, there were no repeated letters, so it's just a straight up permutation or factorial. All right, from a group of 10 boys and 7 girls, a boy and a girl will be selected to attend a conference. How many ways can the selection be made? So I'm going to pick 1 boy and 1 girl. And in this case, there's, again, a couple of ways I could do this, but the order here doesn't necessarily matter. So in my mind, I'm thinking combinations. I've got 10 boys, and I'm choosing 1 of them. And I'm choosing. Keep in mind, and is often a code word for multiply in probability and counting. And 7 girls, I'm going to choose one of them. Since I'm only choosing one, I could just say 10 times 7. It's not going to matter. I'm going to get the same answer in either case. But I show with the combinations because if it said, hey, let's pick 2 boys and 1 girl, you know, if it was 2 boys and 1 girl, it would be 10, choose 2. How many ways can I pick the 2 boys times how many ways I can choose the 1 girl. So combinations could come into play with these sort of problems. Okay, so number 51. You own 8 travel books. Who owns books anymore? And are taking 4 on vacation. How many ways could you choose the 4 travel books from the 8? So you basically have 2 ways to do this problem. You're either going to do it as 8 travel books per P4, or you're going to choose 8C4. Now, one of these methods is right and one of them is wrong. The real question is, do you understand when the situation is a permutation versus a combination? And in this case, the answer is it's a combination. And the reason is that order doesn't matter. It doesn't matter how the 4 books I take are arranged. It doesn't matter if, you know, my map is first, maybe that's a book, and my, you know, Your Fun Time Guide to Montana is second, or vice versa. How I have the books ordered doesn't matter. The key is, which books do I have, okay, without considering order. So it's definitely going to be a combination. And again, you can use your calculator for this. That would be my advice. And you will get 70. If we did 8P4, not only would we get that 70, but also all of the rearrangements of those 70 groups. Okay, moving along to number 52. 12 balls are numbered 1 through 12 are placed in an urn. I tell you what, all the classic probability stuff talks about urns. Sounds like, you know, Grandpa Ernie's ashes or something. I don't know what's up with the urn, but whatever. 12 balls numbered 1 through 12 are placed in an urn. 1 is selected at random. What's the probability that it's a 7? Well, guess what? There's only 1 ball that has a 7 on it, and there's 12 possible outcomes. It's 1 out of 12. So that's pretty straightforward probability.